Welcome to common equations in related rates problems. So in the examples I did, we've already seen some equations. So we have our volume equations. So volume of a sphere. Volume is equal to 4/3 pi r cubed. We have volume of a cylinder. Volume is equal to the area of the base pi r squared times h. Volume of a cone. We are looking at volume is equal to 1/3 pi r squared h. Again, where pi r squared is that the area of the base of the cone. Volume of a box. We have volume is equal to length times width times height. Those are the kind of the standard volume problems I can think of. We have surface area. So surface area of a sphere is area is equal to 4 pi r squared. Surface area of a cylinder we have area is equal to 2 pi 2 pi r squared. So those are the two circles, plus the circumference 2 pi r times the height h. Surface area of a cone surface area is equal to, we have the base pi r squared plus pi times r times the length of the slant, which is square root of r squared plus h squared. Surface area of a box, we have that area is equal to 2 length times width plus 2 width times height plus 2 length times height. So again, these are kind of the standard surface area problems you might, or situations you might run into. Then of course we just have our usual area. So area of a circle, we have area is pi r squared. Of a rectangle, area is length times width. Of a triangle, area is 1/2 base times height. Beyond that, then we have perimeter or circumference. So a circle, we have the circumference is 2 pi r And of a rectangle, perimeter is 2 times length plus 2 times width. Beyond this, the other geometry things you'll have, we have Pythagorean theorem. So Pythagorean theorem comes in handy. If we have a right triangle, the 2 legs and then the hypotenuse labeled C, we have a squared plus b squared is equal to c squared. You also might need right triangle trig. So if we have our angle theta, I'm going to call this hypotenuse, opposite, and adjacent. Right? So just a reminder, sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. And then cosecant is the reciprocal of sine. So cosecant is hypotenuse over opposite. Secant theta, we are looking at hypotenuse over adjacent. And then cotangent theta is adjacent over opposite. So all of these can come in handy. And then one more type of situation you might see is with similar triangles. So with similar triangles, you usually will see it literally with one triangle inside the other. It's the most common. So I'm going to label the small triangle with lowercase letters and the large with uppercase. So we have A, B, and C, just like with the Pythagorean theorem. And then the large triangle, we have A, B, and I'm going to add a curl to my capital C so it's clear. So again, similar triangles, what we have is small is to large, as small is to large, as small is to large. So the lowercase a is to capital A, as lowercase b is to capital B, as lowercase c is to capital C. So you usually won't need all 3 of these. Usually you'll most often would use just the legs. So we'd use the first 2 parts of that equation. So all of these equations can be useful when you're trying to write your related rates problem, or trying to write the equation that you will then differentiate for related rates. They can also come in handy for determining the all of the information you need for plugging in. So those are your useful equations. These same equations will also be useful for optimization problems.